So hi everyone. So now I want to discuss some more interesting problems on Lagrange's mean value theorem. Okay. So before going to the problem, you remember this result. So that is if f dash of x is greater than 0 at all points of the interval AB, so then f of x is strictly increasing function. F of x is strictly increasing. Increasing means, so if you take this interval, okay, so it is like this only. The function is strictly increasing. Nowhere it has a flatness. ಅಂದ್ರೆ ಎಲ್ಲೂ ಕೂಡ ಹಿಂಗ್ ಫ್ಲಾಟ್ ಕೂಡ ಆಗಿರೋದಿಲ್ಲ, ಎಲ್ಲೂ ಕೂಡ ಡಿಕ್ರೀಸ್ ಆಗೋದಿಲ್ಲ. So then we say it is a strictly increasing function. Yes, based on this, by using this result, we have to prove some more interesting results. So that is show that x by 1 plus x is less than log of 1 plus x, that is less than x. To prove this result, so first you consider the first result is we have to show that x by 1 plus x is less than log of 1 plus x, that is less than x. Yes, to prove this result, you consider that let f of x is equal to, you define a function f of x is equal to log of 1 plus x minus x by 1 plus x. So this is the new function we define. In the interval, you take that interval is some 0 to infinity, like that. Okay, so this is the function f of x. Now you take its differentiation, f dash of x. So f dash of x is equal to, f dash of x means differentiation of f of x. So f dash of x is 1 by 1 plus x into differentiation of 1 plus x is 1 minus. To differentiate this x by 1 plus x, you use quotient rule, that is denominator into differentiation of x numerator minus numerator into differentiation of x plus 1, that is denominator. So okay, this is f dash of x. F dash of x is equal to, again that f dash of x is 1 by 1 plus x minus, this is 1 plus x minus x, 1 plus x minus x, this divided by 1 plus x whole square. This x and x cancels. Remaining is 1 by 1 plus x whole square, which is equal to 1 by 1 plus x minus 1 by 1 plus x whole square. Take the LCM. If we consider the LCM gives this f dash of x is equal to, simplify ಮಾಡ್ಕೋಬೇಕಷ್ಟೇ ನಮ್ಮ intention. So f dash of x is equal to, so here that 1 plus x whole square is the LCM. So ಅವಾಗೇನಾಯ್ತು, 1 plus x ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ remaining is 1 plus x. So here remaining in first term is 1 plus x minus 1 plus x whole square is there. 1 plus x whole square cancel with 1 plus x whole square, it is 1 only. So now it is plus 1 cancel with minus 1. Remaining here is x by 1 plus x whole square. So therefore f dash of x is greater than 0 for all x belongs to the interval 0 to infinity. Andre generally positive value ತಗೊಳ್ಳಿ. So for any positive value of x, so for all x belongs to 0 to infinity, f dash of x is greater than 0. So that is, therefore f of x is strictly increasing function. Strictly increasing function. Strictly increasing ಅಂದ್ರೆ ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ ಗ್ರಾಫಲ್ಲಿ ನೋಡಿದ್ವಲ್ಲ, ಸಪೋಸ್ ಇದು 1 2 ಅಂತ ಇಟ್ಕೊಂಡ್ರೆ ಅಥವಾ 1 2 3 ಅಂತ ಇಟ್ಕೊಂಡ್ರೆ 1 2 3 ಅಂತ ಇಟ್ಕೊಂಡ್ರೆ ಇದನ್ನ, ಸೊ ಎಫ್ ಆಫ್ 3 ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಎಫ್ ಆಫ್ 2 ಆಗಿರುತ್ತೆ. ಸೊ ಎಫ್ ಆಫ್ 2 ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಎಫ್ ಆಫ್ 1 ಆಗಿರುತ್ತೆ. ಸೊ ಅದೇ ಥರ 0 to ಇನ್ಫಿನಿಟಿ ಡಿಫೈನ್ ಮಾಡಿದ್ರೆ, ಸೊ ಎಲ್ಲ ವ್ಯಾಲ್ಯೂಸು ಎಫ್ ಆಫ್ 0ಗಿಂತ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಎಕ್ಸ್ನ ಎಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ ಎಫ್ ಆಫ್ 0ಗಿಂತ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ಇಟ್ ಈಸ್ ಅ ಸ್ಟ್ರಿಕ್ಟ್ಲಿ ಇನ್ಕ್ರೀಸಿಂಗ್ ಫಂಕ್ಷನ್. ಸೊ therefore f of x is greater than f of 0 for all x belongs to 0 to infinity. Okay, so now what is f of x? F of x andre eno? F of x is log of 1 plus x minus x by 1 plus x, that is greater than f of 0. What is f of 0? So f of 0 ಅಂದ್ರೆ f of x ಗೆ 0 ಹಾಕಬೇಕು. f of x ಗೆ 0 ಹಾಕಿದ್ರೆ ಏನು ಬರುತ್ತೆ? So what is f of 0? F of 0 is equal to log of 1 plus 0 minus, if you put x0 it is 0 only. So log 1 means 0. 0 minus 0 it is 0. So f of 0 is 0. So you directly take f of 0 value is 0. So now log of 1 plus x is greater than x by 1 plus x. You take this inequality is 1. Similarly, to prove this complete result, istunu prove madlikke you define one more function such that the new function is g of x. G of x is equal to x minus log of 1 plus x. You take second function, let g of x is equal to x minus log of 1 plus x. Now you take its differentiation, g dash of x. G dash of x is equal to differentiation of x is 1 minus differentiation of log of 1 plus x is 1 by 1 plus x into 1. If you simplify this, it is 1 plus x minus 1 divided by 1 plus x. This plus 1 cancelled with minus 1, which is equal to x by 1 plus x. X by 1 plus x is greater than for all positive values of x. So for all x belongs to the interval 0 to infinity. That means g dash of x greater than 0 ide andre, so according to this result, f of x is strictly increasing function agutte. So therefore g dash of x is greater than 0, which implies that g of x is strictly increasing function. G dash of x greater than 0 implies that g of x is strictly increasing function. Strictly increasing. So it is a strictly increasing function. So that means what? Which implies that g of x all values is greater than g of 0. G of x na ella values g of 0 ginta ಜಾಸ್ತಿ ಇರುತ್ತೆ. What is g of x? G of x is x minus log of 1 plus x. So is greater than g of 0. G of 0 ಅಂದ್ರೆ x ಗೆ 0 ಕೊಟ್ರೆ ಇದು 0 ಆಯಿತು. log 1 ಅಂದ್ರೆ ಅದು ಕೂಡ 0 ಆಗುತ್ತೆ. So that is 0. Which implies that x is greater than minus log of 1 plus x na ಈ greater than ಇಂದ ಈ ಕಡೆ ತಗೊಂಡ್ರೆ plus log of 1 plus x ಆಗುತ್ತೆ. Actually ಅದನ್ನ ಹಾಗೆ ಹೇಳಬಾರ್ದು, add log of 1 plus x on both sides ಅಂತ ಹೇಳಬೇಕು. So then minus log of 1 plus x cancel with plus log of 1 plus x. In the right hand side remaining is log of 1 plus x. So take this inequality is 2. ಇದನ್ನ 2 ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. So from 1 and 2, from the inequalities 1 and 2 we have, from 1 and 2, from the result 1 and 2 we have that, what is the result? 1 is result 1 ಏನಿದೆ, so it is x by 1 plus x is less than log of 1 plus x ಇದೆ. So x by 1 plus x by 1 plus x is less than log of 1 plus x. So log of 1 plus x is less than x ಇದೆ. So log of 1 plus x is less than x. Hence the proof. Hence the proof. Yes, similarly, if you rearrange the terms, you take this inequality is 3. Okay. To prove the second result ಏನಿದೆ ಇಲ್ಲಿ problem ಅಲ್ಲಿ you have to show that 0 less than 1 by log of 1 plus x minus 1 by x, so that is less than 1. ಹೀಗೆ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಓಕೆ, so that is we have to show that 0 less than 1 by log of 1 plus x minus 1 by x, so that is less than 1. Okay, to prove this result, you as you take that result from the result 1, from first result we have what is the first result? It is x by 1 plus x is less than log of 1 plus x is less than x. ಇಲ್ಲಿ ಏನು ಮಾಡೋಣ, you take reciprocal on all the terms of the inequality. ಎಲ್ಲ ಕಡೆ reciprocal ತಗೊಳ್ಳೋಣ. So if you take the reciprocal, 1 plus x by x ಆಗುತ್ತೆ ಇದು ಫಸ್ಟ್ ಒನ್. ಸೊ ಇಲ್ಲಿ ಲೆಸ್ ದೆನ್ ಇರೋದು ಗ್ರೇಟರ್ ದೆನ್ ತಗೋಬೇಕು ರೆಸಿಪ್ರೋಕಲ್ ತಗೊಂಡಾಗ. ಸೊ ಗ್ರೇಟರ್ ದೆನ್ 1 by log of 1 plus x is greater than 1 by x. So now you simplify this. It is 1 by x plus x by x. X by x is greater than 1 by log of 1 plus x. So that is greater than 1 by x. Simplifying this further. Sorry, space is not enough. Yes, this x and x cancels. ಇಲ್ಲಿ x ಮತ್ತು x cancel ಆಗುತ್ತೆ. X and x cancels. Remaining here is 1 by x plus 1 greater than 1 by log of 1 plus x, which is greater than 1 by x. Add minus 1 by x on all the terms of the inequality. Adding minus 1 by x or subtracting 1 by x. Adding minus 1 by x. So in all the inequalities, so then what happens here is minus 1 by x plus 1 by x plus 1 is greater than 1 by log of 1 plus x minus 1 by x is greater than 1 by x minus 1 by x. So plus 1 by x cancelled with minus 1 by x, plus 1 by x cancelled with minus 1 by x. Remaining here is 1. 1 is greater than 1 by log of 1 plus x minus 1 by x. So that is greater than 0. So 1 by x minus 1 by x is 0. So this is the second result. What is the second result is 0 less than 1 by log of 1 plus x minus 1 by x. Yes, the same thing, 0 less than 1 by log of 1 plus x minus 1 by x, and this is less than 1. So that is the quantity less than 1. That is, this is less than 1. That same thing is there. Okay. Hence the proof. Hence the proof. Okay. So 1 minute. Okay, sorry. Yes. Using the function f of x is equal to tan inverse of x, show that b minus a by 1 plus b square is less than tan inverse of b minus tan inverse of a is less than b minus a by 1 plus a square, where 0 less than a less than b. So to prove this result by using Lagrange's mean value theorem, so you take the function first. Let given function f of x is tan inverse of x is defined in the interval ab, is defined in the interval ab. So now you take that is obviously f of x is continuous function, since first clearly f of x is continuous. So clearly f of x is continuous in AB. And next is differentiability. You take f dash of x. F dash of x is equal to, it is 1 by 1 plus x square. So that is also exits in the interval AB, because the values of a and b are positive. So because a is greater than 0 and b is greater than a, so that exits in AB. Okay, so then there exists at least one point, C belongs to AB, such that f dash of C is equal to f of b minus f of a by b minus a. So therefore there exists C belongs to AB such that f dash of C is equal to f of b minus f of a by b minus a. So this is by using Lagrange's mean value theorem. So therefore it is according to Lagrange's mean value theorem, the exit C belongs to AB such that f dash of C is equal to f of b minus f of a by b minus a. So then what is f dash of C? F dash of x andre 1 by 1 plus x square ಇದೆ. F dash of C andre it is 1 by 1 plus c square is equal to, it is f of b. What is f of b here is, f of b andre f of x andre tan inverse of x, f of b andre it is tan inverse of b, f of a andre it is tan inverse of a, this divided by b minus a. Okay, you take this result is 1. ಇದನ್ನು 1 ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. 1 by c square is equal to tan inverse of b minus tan inverse of a by b minus a. So again you take that c is the value that exits in between AB. C is the value that exits in between AB. C belongs to AB implies that C belongs to the interval AB implies that A is less than C, C is less than B. So first you take that A is less than C, which implies that A less than C ಇದೆ ಅಂತಂದ್ರೆ, so then you take that A square is less than C square. A less than C ಆಗಿದ್ರೆ A square less than C square ಆಗಿರಲೇಬೇಕು, which implies that 1 plus A square is less than 1 plus C square, which implies that ಎರಡೂ ಕಡೆ ರೆಸಿಪ್ರೋಕಲ್ ತಗೊಳ್ಳೋಣ. ರೆಸಿಪ್ರೋಕಲ್ ತಗೊಂಡಾಗ ಲೆಸ್ ದೆನ್ ಗ್ರೇಟರ್ ದೆನ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಅಂತಂದ್ರೆ ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 2 ಲೆಸ್ ದೆನ್ 3 ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. 2 ಲೆಸ್ ದೆನ್ 3 ಇದ್ರೆ ಇಫ್ ಯು ಟೇಕ್ ರೆಸಿಪ್ರೋಕಲ್, ಸೊ 2 ಲೆಸ್ ದೆನ್ 1 by 2 ಲೆಸ್ ದೆನ್ 1 by 3 ಬರೀಲಿಕ್ಕೆ ಆಗಲ್ಲ. ಯಾಕೆಂದ್ರೆ 1 by 2 ಅಂದ್ರೆ ದಟ್ ಈಸ್ 0.5, 1 by 3 means it is 0.3. 0.3 is less than 0.5. ಸೊ ರೆಸಿಪ್ರೋಕಲ್ ತಗೊಂಡಾಗ ಲೆಸ್ ದೆನ್ ಇರೋದು ಏನಾಗುತ್ತೆ, ಗ್ರೇಟರ್ ದೆನ್ ಆಗುತ್ತೆ. ಸೊ ಇಫ್ ಯು ವಾಂಟೆಡ್ ಟು ಟೇಕ್ ದ ರೆಸಿಪ್ರೋಕಲ್, ಇದು ರೆಸಿಪ್ರೋಕಲ್ ತಗೊಂಡ್ರೆ 1 by 1 plus a square is greater than 1 by 1 plus c square ಆಗುತ್ತೆ. So take this inequality is 2. Again you take this result, c less than b ಅಂತ ಹೇಳಿದ್ದಾರೆ. You take that one, c is less than b. Again that c less than b, which implies that c square is also less than b square, which implies that, so take add 1 on both sides, 1 plus c square is less than 1 plus b square. So which implies that 1 by 1 plus c square is greater than, I am taking reciprocal here. So that is the 1 by 1 plus c square is greater than 1 by 1 plus b square. You take this inequality is 3, then 3 anta itkolona. Okay. So now from 2 and 3 we have, from the result 2 and 3 we have that is 2 ಏನಿಡುತ್ತೆ 1 by 1 plus a square is greater than 1 by 1 plus c square ಅಥವಾ ಸೊ ಇದನ್ನೇ ಫಸ್ಟ್ ಬರೆಯೋದಾದ್ರೆ ಸೊ ವಾಟ್ ದಟ್ ರಿಸಲ್ಟ್ ಇಸ್ ಆಕ್ಚುಲಿ ಎಸ್ a square ಲಾಸ್ಟ್ ಇದೆ. ಓಕೆ, ಅದಕ್ಕೆ ಇದ್ದೇ ಬರೆಯೋಣ ಫಸ್ಟ್ ಫ್ರಮ್ 3. ಸೊ ಎಕ್ಸ್ಪ್ರೆಷನ್ 3 ನ ಹೇಗೆ ಬರೀಬಹುದು ಅಂದ್ರೆ 1 by 1 plus b square, 1 by 1 plus b square is less than 1 by 1 plus c square. 1 by 1 plus c square is less than 1 by 1 plus a square. ಹೀಗೆ ಬರೀಬಹುದು. ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಇನ್ಇಕ್ವಾಲಿಟೀಸ್ 2 ಮತ್ತೆ 3 ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಈಗ ಬರೀಬಹುದು. ಬಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ 1 ಏನು ಹೇಳುತ್ತೆ ಅಂದ್ರೆ, ಸೊ equation 1, 1 by 1 plus c square is equal to tan inverse of b minus tan inverse of a by b minus a ಅಂತ ಹೇಳುತ್ತೆ. ಸೊ in place of 1 by 1 plus c square, you write that tan inverse of b minus tan inverse of a by b minus a. Okay, if you write that here, it is 1 by 1 plus b square. 1 by 1 plus b square is less than tan inverse of b minus tan inverse of a, this divided by b minus a. So that is less than 1 by 1 plus a square. So multiply all the terms by b minus a. b minus a in the all terms multiply madidre b minus a divided by 1 plus b square is less than, positive values ಮಾತ್ರ multiply ಮಾಡಬೇಕು, ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂಸ್ ನ multiply ಮಾಡಿದ್ರೆ ಲೆಸ್ ದೆನ್ ಗ್ರೇಟರ್ ದೆನ್ ಅಂತ ಚೇಂಜ್ ಮಾಡಬೇಕು. ಬಟ್ ಇಲ್ಲಿ ಎಲ್ಲ ಪಾಸಿಟಿವ್. ಹೇಗೆ ಪಾಸಿಟಿವ್ ಅಂದ್ರೆ a ಲೆಸ್ ದೆನ್ b ಇರೋದ್ರಿಂದ b ಮೈನಸ್ a ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ. ಸೊ b ಮೈನಸ್ a by 1 plus b square is less than tan inverse of b minus tan inverse of a, this divided by b minus a into b minus a, that is less than b minus a divided by 1 plus a square. Here one of this b minus a cancels. E b minus a cancel ಆಗುತ್ತೆ. So now b minus a divided by 1 plus b square is less than tan inverse of b minus tan inverse of a, that is less than b minus a divided by 1 plus a square. So this is the required final result. Okay. So ಇದೆಲ್ಲ ಪ್ರೂವ್ ಮಾಡಬೇಕಾಗಿದೆ ನಾವು. tan inverse of b minus a by 1 plus b square is less than tan inverse of b minus tan inverse of a by b minus a by 1 plus a square. Okay. So that one we proved here. Okay, I continue some more problems in next class.